Module 5, Part 3 covers solving equations using the zero factor property. So we're going to have to use all the factoring skills we learned in Section 1 and Section 2 and now use them to solve these types of problems. So please make sure you're completing your guided notes as you follow along. So a quadratic equation in one variable is something that looks like this. Ax squared plus bx plus c equals 0. So one we've probably seen a couple times because it's a go-to example of mine is x squared minus x minus 6 equals 0. Where a, b, and c are real numbers, and as long as a doesn't equal 0, this is a quadratic in what we would call standard form. So the zero factor property says this: if a and b are numbers and a times b equals 0, then either a is 0, b equals 0, or both equal 0. So for this example, I have an already factored quadratic equation. I've got x plus 6 times 2x minus 3 equals 0. So what we're going to do is we're going to set both of them equal to 0, and we're going to solve for x. We set every factor we have equal to 0, and we solve for x. On the left, I subtract 6 from both sides. X is negative 6. On the right, I add 3 to both sides. I get 2x equals 3. So x is 3 halves. Instead of solving one equation, I solve 2. So I find that x is either negative 6 or 2/3. It's both of those. Both of those are our answers. And as we'll see as we move along this course, what we're finding is we're finding our x-intercepts, because what we're doing is we're letting y, or f of x, equal 0. And since the graphs of these, and this is like a big prequel, but the graph of quadratic functions all look like this. They look like a parabola. What we've found is we found our two x-intercepts when we set our function equal to 0 and factor. We're finding our x-intercepts. In case you want a little prequel of like why we're doing this, like what's our motivation here. So our steps to solving a quadratic function by factoring are first to make sure we write it in standard form. Then we can factor it, use the zero factor property, find our solutions, and check our answers if we're a little nervous or taking an exam, just to make sure we're right. So for our first example, I have 2x squared plus 3x equals 2. This is not in quadratic form. I need to move the 2 over and get one side equal to 0. And that might be a little counterintuitive because I've always had as, oh, we're trying to isolate our variable. Now I'm asking you to move everything together with the variable. Now I can factor. I need to find the factors of AC that add up to B. AC is 2 times negative 2. That's negative 4. C is 3. So what are some factors of negative 4 that add up to positive 3? How about negative 1 and 4? So I've got 2x squared minus x plus 4x minus 2 is 0. And then I factor by grouping. 2x times x minus 1 plus 2x, not 2x, just a 2 there. I factor out a 2 times x minus 1 equals 0. I collect my greatest common factors. 2x plus 2 times x minus 1 equals 0. So I've factored my polynomial. I'm done with this second step. Now I need to use the zero factor property. So I have to set each of these terms equal to 0 and solve. So I'm going to have two x plus 2 equals 0. I subtract 2 from both sides. I get 2x equals negative 2, so x is negative 1. And I have our second equation, x minus 1 equals 0, so x equals 1. My values of x, my x-intercepts for this quadratic, are negative 1 and 1. So here we have quite a few more examples, and we're going to do all of them because it's good practice. So for problem 1, I have 4x squared equals 4 minus 1, I need to have this all written as a quadratic function equal to 0. So I'm going to move the 4x to the left, and I'm going to move the 1 to the right. And the reason I didn't move the 4x squared is I didn't want to deal with a negative leading coefficient, because remember, we really don't like those. So I'm going to have 4x squared minus 4x plus 1 is 0. My AC in this case is 4 times 1, which is 4. So what are some factors of 4 that add up to negative 4? Well, I could have 1 and 4. That's not quite right. Negative 1 and negative 4, still not quite right. 2 and 2, negative 2 and negative 2. There we go. That's our winner. Negative 2 times negative 2 is a positive 4. Negative 2 plus negative 2 is a negative 4. I've got 4x squared minus 2x plus 1 is 0. And then we factor by grouping. The greatest common factor of my first two terms is 2x. The greatest common factor of my second terms is a negative 1. I collect my greatest common factors and what they left behind. And I see here I've got 2x minus 1 squared. I could rewrite it like this if I wanted to. But I'm supposed to take each of these terms and set them equal to 0. And I can do that, and I can do that twice. The issue there is I'm just going to get two values. I'm not going to get two values. I'm going to get one value. They're both going to have the same answer. So if I have 2x equals 1, x is 1/2, and x is 1/2, and we've been writing these answers in set notation. And if I have the same number appearing twice, I only write it once. Eventually, when we learn to graph these, what you're going to see here is that this parabola doesn't cross my x-axis. It only briefly touches it when x is 1/2. So that was going on with our first example. Our only solution is a positive 1/2. In problem 2, I have 4x squared minus 20x equals 0. Now for this one, I can't find the factors of AC that add up to B because there's no C. But I can see that, okay, they have a greatest common factor. So in our general approach to factoring, we talked about in the last video, what you want to do is you always want to pull out the greatest common factor first and then factor as needed. So here the greatest common factor is definitely going to have an x in it, but it's also going to have a 4. So I have 4x times x minus 5 equals 0. So now I have these two terms, and I set them equal to 0. 4x equals 0. I divide both sides by 4, so x equals 0, and x can equal 0, right? That's a real number. We can represent it on the real number line. We're good to go. And then I have x minus 5 equals 0. I add 5 to both sides. I get x equals 5. So my solution set would be 0 and 5 for this problem number 2. For problem 3, I've got 3x squared minus 108 equals 0. Well, I want to pull out the greatest common factor, which is a 3. So I'm going to have 3x squared minus 108 divided by 3, 36, equals 0. Now this is a difference of two squares, so my b term is 0. I could find the factors of AC that add up to B in order to factor that, but by now, with all the practice we had in the last video, we should see that this is going to factor to x plus 6 and x minus 6. This is the product of a sum and a difference. Gets us to this difference of squares. This 3, I could set it equal to 0, but we kind of ignore it. I have x plus 6 equals 0. X minus 6 equals 0. So x is going to be negative 6 and x is going to be 6. This is my solution set. And I write that in squiggly brackets because we are using set notation. The reason I kind of ignore this 3, and I didn't mean to rush over that, but when I set 3 equal to 0, that's a false statement. That doesn't make any sense. We kind of ignore it. I didn't ignore it in this second example when I pulled out a factor of 4x, and that left me with x minus 5, because there was an x term in there. So we want to set all those x terms equal to 0. Problem 4, I have 2x squared plus 5x minus 7 is 0. I want to find the factors of AC that add up to B. AC is negative 14. Some factors of negative 14 that add up to a positive 5 could be negative 2 and 7. So I have 2x squared minus 2x plus 7x minus 7 is 0, and I factor by grouping. The greatest common factor of 2x squared and 2x is a 2x. The greatest, and that just leaves me with an x by itself when I pull that out. There we go. The greatest common factor of 7x and 7 is 7. I collect the greatest common factors and what they left behind. So I've fully factored this. Now I use the zero factor property to set each of the factors equal to 0. I have 2x is negative 7, so x is negative 7 halves. And I have that x is 1. So my solution set, my solutions are negative 7 halves and positive 1. And that was problem 4. For my last example, problem 5, I first want to start out by getting everything set equal to 0. So I'm going to add 6x to both sides. So I have my equation equal to 0 on the right. That's a habit I'm in, of having my zeros be on the right, but I could have moved everything else over to the left as well. I go ahead and pull out the greatest common factor, which is going to be an x, but I got to make sure it's a negative x because we've got a negative leading coefficient and we don't like that. That leaves me with x squared minus x minus 6 is 0. And I say, okay, what are the factors of AC that add up to B? And that's going to be a negative 3 and a positive 2. And because my leading coefficient is 1, I can go ahead and rewrite this as x minus 3, x plus 2 equals 0. Now this is a degree 3 polynomial. This isn't a parabola. It's going to look something, well, actually technically, it's going to look something like this. It's got 2 changes of directions. So I have 3 terms that I have to set equal to 0. And I'm going to have 3 solutions because this graph would cross my x-axis 3 times if I was to graph it. So I have x is 0, x is 3, and x is negative 2. So my final solution set would be negative 2, 0, 3. It's a good habit to be in to write them from smallest to largest. Another tool we can use other than the zero factor property is the square root property. And we're going to be talking about square roots and radicals. That's what this symbol is. This is a radical symbol. More in module 7, but we can use them as a tool for us now. So if u is an algebraic expression and d is a positive real number, then u squared equals d has exactly 2 solutions. U equals the square root of d and u equals the negative square root of d. We can also write this as u is plus or minus the square root of d. So let's do a few examples. This first one should seem the most straightforward. If I have x squared equals 9, what could I plug in for x squared in order to get a positive 9? Well, that could be 3 or negative 3. And I could have solved this using the zero factor property if I wanted. You don't have to write this down. This is just kind of showing you if I move the 9 over and set it equal to 0, and then I factored it, I would get 2x values. X is negative 3, and x is 3. But I could also use the square root property. So if x squared equals 9, then I take the square root of both sides. I would x is plus or minus 3, which I could write as -3 and a +3. For problem 2, I have -5x is equal to -125, and I could divide both sides by -5 to get that x all by itself. I have x squared is 25. That's a perfect square. That's kind of our hint here. And I can go ahead and take the square root of both of these to get x's plus or minus 5. Examples 3 and 4, a little more complicated. Let's take a look at those. So I have x plus 3 squared is 16. So if I take the square root of both sides, I'm going to have x plus 3 is plus or minus 4. So let's break that up into two equations. I have x plus 3 is positive 4, and x plus 3 is negative 4. That would mean x is going to be 1, and x is going to be -7. That would be my solution set to this equation. So last example, I have -4, x minus 2 squared is -36. I want to get this square all by itself, so I divide both sides by -4. That gives me x minus 2 squared is 9. I take the square root of both sides. X minus 2 is plus or minus 3. So x minus 2 is a -3, and x minus 2 is a +3. That means x is 5, and x is -1. So my solution set for this last example would be -1 and a +5.